Okay, so we are looking at the point of intersection between two functions. Right, so what this is we have two functions and we are wanting to find the points of intersection, so where they meet each other. So if we have, for example, a function like this, which is y equals x cubed minus 17x minus 25, and then we have another function. This could be a polynomial, but more often it will be a straight line. And we've got y equals 2x plus 5. Okay, so our one real step for solving these is to set the equations equal to each other and solve. Right, and careful for these ones because quite often it asks for the coordinate. So make sure that you give your answer as a coordinate, not just the x value, but need the y value too. Right, so we set these equal to each other. So we're going to get 2x plus 5. So let y equal y. So we get 2x plus 5 equals x cubed minus 17x minus 25. So we're going to get it equal to 0 so that we can find the roots, which will give us our values for x. So set it equal to 0. So we take away 2x from both sides, so our x cubed stays the same, so minus 19x. And we're going to take away 5 from both sides, which gives us minus 30. Right, so from here it's just solving a polynomial equation. So we want to get a factor which is equal to 0. So if we try, say, let's go for minus 2, so it's a factor of 30. So we can try minus 2. So if we go x equals minus 2, then we're going to have minus 2 cubed minus 19 times minus 2 minus 30, which is minus 8 plus 38 minus 30, which is 0. And that hesitation there was me just doing 19 times 2 in my head. Right, so therefore x plus 2 is a factor. Okay, so once we've got our factor, we know what to do. We do synthetic division. I'm going to do it over here where I've got some space. So remembering it's our x cubed, then our x squared, then our x, and then our constant. This is one to be careful because our x cubed is 1, our x squared is 0. Then we've got minus 19, and then we've got minus 30. And we have minus 2 out here, so we take that down, we get 1. Multiply it by the minus 2, we get minus 2. Add those two together, we get minus 2. Minus 2 times minus 2 is 4. That gives us minus 15 times minus 15 by 2, we get 30. So we have a remainder of 0, which is exactly what we were looking for. So that means that we've got, therefore, we have x plus 2, and then we've got x squared minus 2x minus 15. And all of that is equal to 0 because we've started our factorization process. So we've got x plus 2, and then we're going to have x and x. Two numbers that multiply to give us minus 15 but add to give us minus 2 are going to be plus 3 and minus 5. Okay, so that gives us our x's. X is minus 2, x is 3, and x is 5, and it should be minus 3, not 3. Okay, so you can see we've got 3 points of intersection on our graph. Our graph's not exactly correct. Apologies, I did say that already, I think. However, okay, so we now need to find the coordinates for those. I've not quite got the space on here, so we'll go on to the next page. Okay, so I've taken across the most important information. So we've got x is minus 2, x is minus 3, and x is 5. And we've got our two equations. So we want to find the coordinates, because points of intersection are always coordinates. Okay, so we call them points of intersection POI. Okay, and so when x equals -2, we've got to substitute -2 into one of our equations. Presumably, we're always going to pick the easier one. So 2 times -2 plus 5. So that's -4 plus 5, which is 1. So therefore, we've got the point -2, 1. Okay. Next one, when x equals -3, y is equal to 2 times -3 plus 5. So that's -6 plus 5, so -1. Okay, so we've got -3, -1. That's where my graph wasn't quite right. And when x equals 5, we've got y equals 2 times 5 plus 5, which is 10 plus 5, 15. So we have the points 5, 15. So those are our 3 points of intersection for this graph. Okay, so when we are doing points of intersection, the big things to remember are to set your equations equal, rearrange so they're equal to 0, and then factorize and look for the roots, and the roots give you your values of x for your points of intersection, and then you need to find the y by substituting into the equations. Right, so if you need any more examples of this, let me know. Talk to me in class if you're lucky enough to be there. And otherwise, like, comment, subscribe, please. The next video is to do with the last part of this, which is using the discriminant to determine unknown coefficients before we move on to the next chapter.